Okay, so here's the note sheet. Here's what we're going to start off with. So write this down again. I should have asked somebody, what are these side measures of a 45, 45, 90, and a 30, 60, 90. But it really is, we're going to use these. And then I'm going to introduce coordinate trig, and then these come into play. Now this is going to be our new life. Oh, I forgot why. I want to go back to the calendar real quick, but just make sure you know that the side opposites of 45 are A and A. We make it a number though, so we're going to make it 1 every time. So A will be 1, so it would be 1, 1, and then this side would be whatever A is, which is 1 root 2, right? And then those are the side measures you must have memorized. Where's Ethan going? All right, and then the sides for a 30, 60, 90. We will call the side opposite the 30 A, or let's just make it 1. Remember that, because when your number comes up, when I call you to answer questions, we're going to need to know, these things. And then whatever the side opposite of the 30 is, A, the side opposite of the 60 is A times the square root of 3, or if A is 1, 1 root 3. And then the side opposite of the 90 is 2 times 1, or 2. Those are the ones that we're going to use the most. 1, 1 root 3, and 2 for 30, 60, 90. Because all 30, 60, 90s are proportional with this little relationship, that's why we can say this, I guess. All right, back in the day, this was chapter 13 in our Algebra 2 book. Don't ignore the chapter. I'm not even sure how much we're going to use the book, as we're going to jump around with this stuff here. So first thing we're going to have is angles, an angle measure in a coordinate plane. Now, this is going to be weird, and I am going to go back to the calendar. And I'll show you something else that I put in here. Trig, and I don't care if you were taking notes, go back to that. No, watch me, listen. Trig in the real world. Now I had Sammy, my daughter, talked about, boy, Dad, when I grow up, I want a really big, nice house. Here, I have some pictures from Pinterest, what I want my house to look like. Brick, and big staircases and all this. And they go, that stuff just doesn't come to you. This is the point of going to school and doing as well as you can in school, so you open up these opportunities depending on what you want to be, so you can make the money that allows you to get a house like this. So it just doesn't happen. We have these conversations all the time. So I share these things on my calendar for those that understand that. The internal locus of control, the why are we in school kind of thing. It's so you open up some opportunities for yourself later in life, so you can have the things that you might want. And that's the conversation I just had with her over the weekend. So this is going to be kind of weird today. I often get students all the time say, why coordinate plane trigonometry? What is going on here? What's the point of this? And that's when I share things like this. I got to wait for this to keep going. It's got to start doing a video here. And I think it's taking so long. There we go. It's an ad. Baker burn. There we go. Good. All right. Very loud, too. All right. Real life applications of trig. Look at this. Can't build this bridge without trigonometry and using those ideas, architecture and engineering. Very important. Music theory and production. Anyone musically inclined? I remember going to like a SeaWorld type thing, and I think I just started teaching, and they had the sounds of a whale mathematically described, because sound waves go in what's called sine curves, the graph of a sine cosine function. So I found that very interesting. I saw this complicated math structure. I understood and recognized the trig in it that described or mirrored what sounds of a whale would be. Very interesting, right? So even in music, of course, electrical engineering. I talked about engineering with someone that my daughter plays basketball with, their parents. Certainly manufacturing. Anyone wants to be a business degree or a business person, definitely. Then this article comes into other articles where specifically in architecture, where's trigonometry? I just kind of glanced over these things. And then real life uses of the Pythagorean theorem, another bridge, a fantastic looking bridge there. Architecture, navigation for sure, actually space, knowing where planets are, so on and so forth. There was some stuff about that in the very beginning of this article, talking about that, how ancient people, that's how we knew and learned more and more about space and so on and so forth. So kind of an interesting article. There's for you if you want. I looked at parts of it. Oh, it gets mad at me whenever I go to different things and doesn't let me do this stuff. Okay, so what we're going to do is we're going to have what's called coordinate trigonometry. That's in 30, 60, 90s, 45, 45, 90s are going to also be get into here. So what I have here is a coordinate plane and some things to remember, like the quadrants, because I'm going to ask you a lot of questions today. What quadrant am I in? And if you don't know which way the quadrants go, then we got a problem, right? So we got to identify that first. Right, 1, 2, 3, 4. Those are the 4 quadrants right there. What we're going to do is stick angle measures in this coordinate plane. Then we're going to do trigonometry of angles in this coordinate plane. Now, why a coordinate plane? You know, let's think about navigation. The Earth is in a coordinate plane. Lines of latitude and longitude, that's exactly what that represents. All right, so we can find locations on there. Even an engineer, to think about what they have to do, they'll put it on a piece of paper first before they actually go to production or you know, give their designs to the production team. So on a piece of paper, things have locations. So what's probably good to do is to coordinatize everything so we know where these precise locations are for you know, certain objects or certain things that make up that object. So we really got to get over that. It's a very big, I mean, my CAT students all semester long, coordinate trig comes into play. We talk about what we're doing today all year long. So we just got to get over that and then and learn these things here. So here's the first thing. The initial side, when I'm talking about coordinate plane trigonometry, is always the positive x-axis. That is always where your angles are going to start. I'm going to draw some angles after I show you a couple other things. But the terminal side, we need 2 sides to make an angle. So the initial side is always the positive x-axis. The terminal side could be anywhere, in any of the 4 quadrants, or even on an axis. So that's what standard position is. Sorry for my bad writing here. It's an angle whose initial side is the positive x-axis. And then I just stopped. The terminal side could be anywhere. I didn't feel like writing that. All right. So here's your first thing. I think I just have a general statement down here. The measure of an angle is the amount of an opening between the rays as one ray rotates about another. Sure, so we need 2 sides, but here's the big kicker. Hopefully you can see this down here. If the amount of opening is measured in a counterclockwise direction from the initial side to the terminal side, the measure of the angle is positive. I don't know if you have a clock anymore, you see any of these old-fashioned clocks, but clocks used to have numbers on them, not your fancy little iWatches that do everything. Okay, is that a 9? Yeah, good. So back in the old days, we used to have clocks with arms on them, like a minute hand, a second hand, and an hour hand, right? And all of the hands go this way, 3, 6, 9. That's a clockwise direction, right? So if I go counterclockwise, and then notice this, math, a lot of times math, it seems like counterclockwise is the norm. See, because even when we name the quadrants, we name them 1, then 2, 3, 4. We go in a counterclockwise direction to name the quadrants. So I always think positive is normal and negative is not normal, or positive good, negative bad. So positive in math is counterclockwise. It's going in this direction. And I'm going to give you an angle measure for this. We're going to pretend that this is like 115 degrees. And that should be a reasonable guess. You should know that this is more than 90, but not quite 180, right? And getting used to those situations there. Okay, so first thing to learn, when I have a positive angle measure, starting at the positive x-axis, counterclockwise. Therefore, the next sentence, if it is measured in a clockwise direction, the measure is negative. So the only point of positive and negative angle measures is which direction am I going? And I made this one looking a little bit more of an angular move than this one, so I'll say negative 158 or something like that. I'm just making up angle measures, guys, okay? But that should be a reasonable makeup because it is bigger than negative 90, and it is not as big as negative 180. All right, so we should have a good idea why I picked that angle measure. The guess, right? Okay, so that's number 1. right? Knowing how to construct angle measures in standard position is what this is called. This is what standard position is. Angle starting at the positive x-axis, and that could either go positive or negative. On the angle measure. All right, and then there's something else you have to understand. Probably for the first time in your life, we're going to have angle measures greater than 180. We're actually going to have angle measures greater than 360, because 360 is just a full rotation, and that's what our next thing is going to be. How do we get angles that are bigger than that? And we'll talk about that in our future situation here. This is what I want to do next. Okay, and go ahead and feel free to try to draw this, but this might be the value of printing the notes as well if anyone has done so. On your homework too, the first 3 questions take up the whole front page, because I have this picture in the question. I have this circle with all these sides labeled. Here's what we're going to do, and I may start asking people as we get one at a time, bring questions here. So we know this is what we're going to do. We're going to hack this circle up into popular angle measures that you're going to deal with this week, let's call it. And then my CAT students, the whole semester, they got to be a master of this circle that I have here. We're actually doing the unit circle today with my CAT students as well. Not today, tomorrow, in my 5th, 6th, 7th. So the first thing is, what's that angle measure? That's 0 degrees, man. And that just means you didn't go anywhere. So 0 degrees means you have a terminal side that is the positive x-axis. Ethan, Cat, turn on your, I said your last name on the internet, darn it. What's this thing go? No, you know what? Forget that. This is what I did in the other hour. Get the chat ready. Get the chat ready. Let's see who can win. And Ethan, we'll get back to you with specific questions coming up here. In the chat, tell me what, specifically with the sign as well, what is that angle measure? 5, 4, 3, 2, 1. Come on, show that you care. Nice. I think Alessandro, I think I saw you up there first. 180, and it is positive. We're going to name all these angles positive to start off, okay? And then maybe in the chat, do some different things there. Okay, in the chat, in 5, 4, 3, 2, what's that angle measure? 1, 0, boom. Look at the millions of students putting that in there. Love it. Okay, in 5, 4, 3, 2, 1, boom. Oh, I didn't get to see who was first there. I saw someone I thought someone put 90 there. No, the move was 270. And then what you'll find out here is, sorry, struggling with my pen here. 5, 4, 3, 2, 1. Boom. John was ready, had that loaded up. Okay, well, watch this one. You erase this. Get ready in the chat. This is what I'm talking about here. Whoa! In the chat, what's that? 3, 2, 1, go. Nice, Emily Ann, you had that loaded up and ready to go very fast. Sure. And then we could keep going with this forever. We could do 3 rotations. I don't want to talk about illegal activities, but it's snowing outside. What's a 360 in the parking lot, right? And that's when you take your car and you spin and end up right back where you started. You do a full circle. But then couldn't you spin twice? Couldn't you spin 3 times? So on and so on and so forth. So all of these angle measures are landing in the same spot, which means they are co-terminal, same terminal side. Anyway, let's move on. And then these 3, this is where your world's getting, getting into here, getting into these special triangles. So the first nice angle measure we like to note is 30 degrees right there, because you're going to see that makes a 30, 60, 90 right triangle there, and we could do trig on that. Of course, you probably could guess that this is 45. And then this one's actually 60, 30, 90, because what it does is switches the sides when we do trig on that, where the sides are located. The 1 and the root 3 get changed. Okay, now get ready in the chat. In my next quadrant, this angle measure right here is the important one. I will call this later the reference angle that does our trig. with it, and I'm going to note that this is 60 degrees here. In the chat, though, what is this angle measure? 5, 4, 3, 2, 1, go. Nice. You're already getting it. This is 120 degrees, which you're going to find out is a 60-degree reference angle when we do trig on it, and it makes a 60, 30, 90 right triangle. And then we'll talk about the coordinates later. I think you can know where this is going. This next angle measure here is 45. In the chat, what is this angle measure? 5, 4, 3, 2, 1. Maybe a little bit tougher. Good, Sebastian, and all the others that are just right there. Oh, I know what I was going to do. Remind me at the end of this, showing you your awesome grades on the test. That's why I had to stop the video. I thought I was going to show you the test on my mind. Flipped out on that. So I can't show you now because I can't show on the video your grades. And then the last one, this is 30. So what's this? 5, 4, 3, 2, 1. Okay, so it's 150. You will find that these are special little angles that we can do trig without a calculator, right? And that's what's going to happen today. All right, this is 30 degrees. What's this in 5, 4, 3, 2, 1, go? Good. I had that all labeled out there. Very important angle measures. The next one's 45. So what's this angle measure? I lost my pen. Go ahead. 5, 4, 3, 2, 1 as my pen goes. Anyone know what this angle measure is? Okay, if you get my drift here as far as what's going on here. Nobody yet? There we go. Bunch of people. 225. Then the last one in this quadrant 3 is 60 past. So what's this? 5, 4, 3, 2, 1. Good, Jad. See your name up there quite a bit, being at the top here. So you're getting the gist of it, all right? It's either 30 past, 45, or 60, and then what it does is create special angles. Then I don't have much of a color choice here, so I'll go gray. Now, pay attention to which way I go from here. This is the important angle measure. I'm saying this is 60 degrees. So what's that? Oops, lost my pen randomly. What's the angle measure going in standard position in 5, 4, 3, 2, 1. Nobody? There we go, Sebastian. I still don't have my pen. If there's ways I can. That was. Oh, come on, pen. Yes, this happens. I can't get it to work. Okay, I'll just try this. Maybe that'll activate the pen here a little bit. There we go. I guess that's my trick. Okay, I think some people said 300. And then if this is 45, what's that in 3, 2, 1, go. Nice, 315. Good math. And then if this is 30, that's a simple one. 3, 2, 1, go. 330. Nice. Leanne up there quite a bit as well. Okay, those are our special angle measures. Now, I will say this. Remember I told you your radians thing? The radians thing from those other two guys that are real short are perfect to describe and define what a radian is. What I'm going to do is take this circle and convert these angles into radians. And then those are ones that you're going to have memorized or at least know how to work with them. Right? So that's what's going to happen when we talk about what radians are, and then we can do trig on those. And then now you'll know why your calculator has a radian feature instead of just degrees. Again, my pen just stopped. Oh, it's frustrating to understand. This is a thing. Okay, now, Ethan and everyone else, this is where we're going to go ahead and start asking you questions. Okay, so find coterminal angles. By the way, let's go back up in the chat. Let's take that 240. In the chat, if I can get my pen to work, I guess I could do my mouse and then see if the pen activates. Nope. Okay, so I'll have to use my mouse until this comes back. In the chat, what is this angle measure going in this direction? 5, 4, 3, 2, 1, go ahead. Nice. Ooh, a couple of people put positive 120. Look at the answers of everyone else. It's negative because we went in a clockwise direction. And then how did we know it was negative 120? Because negative 120 and 240 add up to become 360 if you made them both positive. You know what? I gotta mess with my pen. Mess with the battery or something. This isn't gonna work. Everything works worse. Back in the day, I had a pen that had a rechargeable battery, and I never had to worry about this. It didn't work on Bluetooth. This is on Bluetooth, but I just think it disconnects or something. Very frustrating. Feels like it's working worse and worse. Yay! Okay, so this is also negative 120 degrees. And then I'm going to share with you the word coterminal. These two angles both land in the same spot, so that's why they're called same, terminal, ending, side, same ending side, coterminal. So Ethan, where does negative 15 degrees land? What quadrant, if I drew that angle, what would that be in?
Fourth quadrant.
Fourth quadrant. So look at the directions. They want you to name this between 0 and 360. So they really want you to name this angle. What's the answer, Ethan?
345.
Moving on. He is correct. And that's how easy this is. Let's go to the next one, Matt. This one not so easy. What do you know about negative 700? Is it more than one rotation?
Yeah.
Is it more than two rotations? Yes or no?
No.
No. So here's what you do. You figure out, okay, it's negative 360 plus what's left over. What do you know about that, Matt? Or what is
240?
Okay, where does negative 340 land? What quadrant? Really, that's what here's negative 700. Oh, let me answer the question first, though. What quadrant does negative 340?
The fourth quadrant?
Oh, remember, that's what I was worried about. I didn't want to give this away. Remember, negative goes clockwise. So there's
First
negative
quadrant.
360, and then it goes 90, negative 180, negative 270, first quadrant, negative 340. So that's where it lands. That's the angular movement. What is this between 0 and 360? Meaning, what's this direct angle measure just from here to here?
20 degrees?
20 degrees. And that's the answer to answer this question. It's all in relation to 360. Notice this plus this, if it was positive, adds up to 360. That's the idea with coterminal. Right? And then Gracie, what's 660? More than one rotation, yes or no?
Yeah, it's more than one.
Is it more than two?
No.
No. What's left over after 360 is taken out of 660?
300.
Where does 300 land? What quadrant?
Is it the fourth?
Fourth. And then what is, well, actually, what's the answer between 0 and 360? We already said it. We already have it up here. And I actually have it drawn here. That ends up coterminal to this. Because really what this one is one full rotation, then this. But what I want is just this. What's that angle measure? It's on the paper.
It's just 300.
It's just 300. So me breaking this down, it kind of probably like, wait, it kind of locked you up a little bit, but that's the answer. Like getting out that full rotation, that is between 0 and 360. So that is the answer, and we can lock it down. Brian, now we got a different thing, right? I don't care if you have to write this down real quick. And I like drawing them. That's why I have these quick coordinate planes for the notes here. Where does 141 degrees land? Brian? Second quadrant. Okay, now, but look at the directions now. This is between 0 and 360. They don't want that. They want just another positive and another negative. Ryan, I'll help you out on this. Here's another positive. Whee! Then go to that. What's that blue angle measure? It's not 360. Here's 360. This is 360. What's the full angle measure that lands at that red side again?
501.
Oh, 360 plus 141, which is, I agree, 501. Oh, no, put that in blue. 501. So it's 360 plus 141. And then, Hannah, now I want this angle measure. One negative, which goes in this direction. What would that be?
Um,
You get it right, I'll explain it to the rest of them.
okay. Negative.
Is negative.
Yeah, negative
Actually, I got to think about it for a second too. You use your calculator too. Although on a test, this might be no calculator part. You just might have to write some math down.
Negative, wait, hold on, now I'm confusing myself.
Okay, you can use your calculator if you want. You know it's over negative 180, I hope, right? So then that should kind of give you an idea of what the relationship between 141 and another angle measure makes this happen.
Negative 1,
Ooh.
9.
Tell me the math you're trying to do. What would you type on your calculator?
501 minus.
Ooh, it wouldn't be 501. Well, it wouldn't be 501. It'd be 141 is involved with some other angle measure. This is a full rotation. What's a full circle?
360.
360. So it's 141 minus 360. That's what it would be. That's the relationship with coterminal angle measures.
Negative 219.
So negative 219. That'd be bigger than negative 180 because we see the movement here. David, negative 289. What quadrant does that land in?
The first quadrant.
I mean, we should know that before we do, any figuring out of this. Should have done that in red. Oh well. What's this angle measure? That's one of our answers.
71.
71 sounds good to me. Yeah, 71, 289. That adds up to 360. Good. And then Genevieve, what does this angle measure? You know what? I have to do another negative. So I have to do this. Whee! And then that. What is that other angle measure? What does that angle measure when I do that extra loop in there? That extra rotation, then negative 289. Oh, we're struggling with this. That's how we went pretty quick on this. So tell me the math, Genevieve. Talk it through. What did I do right here? How much?
That's 360.
What kind of 360 though? Positive or negative is all I'm saying.
Negative.
Negative. And then I did this much. Okay, so what math would I do in order to figure out what this angle measure is? What did I type on my calculator? Negative 360 plus?
Plus 289.
Negative, because I went negative again. So negative 360 plus negative 289. Okay, we got to get this. So what's the answer? Hopefully you have a calculator or someone type it in the chat. I can't think. So 364, 65, 60, 660, is it negative 640, negative 649? That's what I was going to guess. Okay, all right, so we got to pick this up here, guys, because it's just angular movement and it's based off of 360s. All right, that's all it is. All right, and then Jad, 540. Ooh, this is interesting. Where does 540 land, Jad?
I think it lands in between 2 and 3.
Nice, but you know what we're going to say from here on out? This is 360 and then another 180. We're going to say it lands on the positive x-axis. Wrong, the negative x-axis. My bad. Negative x-axis is where it lands. So these are special conditions. I don't know. Maybe on Wednesday we'll talk about trigger those special ones and what we got to do. But that's where it actually lands. So, Jad, what's this angle measure? Just from here to here.
180.
And then Cecilia, sorry. What's this angle measure? I don't feel like changing colors.
Negative 180.
So that one's pretty simple. Okay. One positive, one negative coterminal. Okay. All right. So good. We're at 10:53. Not too bad on time. Good. I only have 3 more examples. Okay. So you can see those here. In your homework sheet, the first 3 questions almost look exactly the same as this. Okay. Because back in the day, I really wanted to focus on these special triangles. I'm trying to emulate this, this unit circle, and you'll find out why it's a unit circle. Maybe we'll talk about it on Wednesday or probably Thursday. Cleaning up this stuff, because all this week we're going to deal with this unit circle and then talk about radians. So in the homework, I wanted you to see, all right, these angle measures that we're going to trig, we're going to snap them in a coordinate plane, right? And then we're going to see the triangle, and we're going to see the side measures, and then we can place SOHCAHTOA. One thing I want you to add, I don't know why I did this back in the day. Maybe I didn't do tan right away. We just did sine and cosine. Let's find all three. So in the worksheet, do find all three on that first page if you can remember. And then the reason I like it is the steps, what you do on these questions. This is what my CAT students have to do. They have to be masters at this. Their test that they just took was questions like I'm showing you right now that they took on Friday and Thursday, depending what group they're in. So I think we're at Miranda. Where does 240 land? What quadrant?
I hit the wrong button. Quadrant, 3.
3 is correct. And then here's what we have to figure out. And I'm going to throw out a new word at you, Miranda. It's called reference angle. All right. And we do spend a lot of time on it with CAT. So not a lot. I do define it specifically. But it's this angle measure right here that I really, really need, that I highlighted. What is that angle measure, Miranda? Just by knowing how you moved, how you got 240, and how you knew it was in quadrant 3.
That would be 60.
Yep, and now we're getting down to what's going to be going on here. So here's the next thing. We have a reference angle, but we're going to make a full reference triangle. So you make your triangle like you make a coordinate happen. So I go left and down. This is actually a coordinate right here. And that's probably going to be in the way of doing my math here. So we're going to find out what is that coordinate right there. All right. And then we're going to drop this back to the origin so that we have a completed triangle. All right. Now, Miranda did her part. Evan, now it's time to start labeling these sides. What is the side opposite to 30 from the beginning of the notes? What do we make that? This has to be memorized. A. But I want to make it a number. What's the easiest number to make A? 1. Evan, what's the side opposite to 60? A is 1, so it is 1√3. What's the side opposite to 90? This is a 90 because that's how I moved. I moved left and down. That's got to be a right angle. So what's opposite 90? 2A or 2 times 1. And that's what we want to do. We want to make it 1√3 and 2. We have a problem, Lauren. This is a coordinate. So I'm saying the coordinate is 1, √3. I don't think so. I went left 1. What kind of move is left, Lauren, in the coordinate plane?
Negative.
And then what kind of move is down in a coordinate plane?
Negative.
This is where your world gets weird. Now, this is not geometry trig. This is coordinate plane trig. The sides can be negative because they're just telling me where am I located, right? And that's the point. So now we have negative sides on a triangle because it's coordinate plane trigonometry, not real world trigonometry of real objects out in the real world. So that's what you need to understand. The last thing you need to do is remind yourself this is a coordinate. If I'm in quadrant 3, it's negative, comma, negative. So all that being said, you still are allowed to play opposite adjacent SOHCAHTOA. Can't overemphasize the importance of the triangle looking like this, emulating coordinate move. X first, then Y. Then you snap back to the origin. So this is always the reference angle, the angle that's attached to the origin, right? There's nothing more I can say about that. Right, so who are we on here? Adrian, now is the time to SOHCAHTOA. Sine of 240 is what we're actually answering with this reference triangle. What's the sine of 240? So
that would be square root of negative square root 3
over. Sebastian, what's the cosine of 240?
It would be
And then notice in the direction, someone asked me this at the end of the notes. What does exact mean? Or does exact mean I have to put the answers with the radicals? Yes, this is no calculator. This will not be a calculator. You will have to do these kind of questions without it. So train yourself. And then Sebastian, let's do the tan of 240 real quick.
it would be
Which becomes, or just square root of 3. Okay? All right, and then that's what you got to understand. You're doing this without a calculator, and you got to know how to move around in a coordinate plane. All right, 649, good. Those people answer those questions for me. Okay, where are we at? Carolina next? Okay. Think about it for a second here. As you're writing your stuff down, Carolina, what quadrant is negative 225? Oh no. Okay, second. Okay, and it's because of this. Next thing I'm going to ask you is, okay, how far have I gone right now? Negative. And then how far have I gone extra? That tells me what kind of triangle this is. So what does this angle measure? When I ask you these questions, the answer is probably always going to be, when we're doing actually no calculator trig, it's either going to be 30, 45, or 60. Sadly, some people say like 35. They're off by 10. No, it should be 45, and that's what you said, because we're doing no calculator trigonometry. You go ahead and turn off your mic. So here is your triangle, X, Y, and then you go back to the origin for the hypotenuse. There's your reference triangle. Okay, John or Jack, what's the sides opposite the 45s? What do we make those? Or 1. And then what's the side opposite the 90? 1 root 2. All right, and then John, since we're kind of running out of students and I have one more example, what is this coordinate? I went left and I went up. Is anyone negative, X or Y? Negative X. So it's negative 1 comma 1. So this is a negative here. Again, it's just for location. So yes, I have a negative angle measure, but negative angle measures and negative side measures being completely two different things. Negative angle measure, just the way you move. That's it. Negative sides, it just depends what quadrant you're in. So the coordinates dictates, or the quadrant dictates what the coordinates are. And that's what we got to make sure we remember. Okay, so moving on, I think we're on Alessandra. What is the sine of 45? And it is this 45. This is the reference angle connected to the origin there. So, I should mark this for you. That makes this the opposite, this the adjacent, and this the hypotenuse always. Go ahead. And it is positive. I'm finishing off. So we are actually finding the sine of negative 225. We're just using this triangle. What's 1 over root 2? What does that become when you rationalize it? Ooh. So we multiply both top and bottom by root 2. I'll zoom in on this. What's the numerator? So it's 1 root 2 over 2. And those that watched that video from a couple weeks back, you remember these ratios, because I did all this with just 45, 30, and 60 drawing the triangle. And then, Emily, what's the cosine? Sorry, zooming back there. What's the cosine of negative 225? And then what do you end up getting for that? And then just go ahead and do the tangent, because that one's pretty easy. Tan of negative 225. But it's just negative 1. Okay? All right, good. All right, and then the last one, we'll finish off with the last students here. Peyton, where's negative 330? What quadrant? First quadrant. What's the reference angle? I'm not drawing it yet. I'm seeing if you can get it. Plus, I'm doing something. It is 30. What's the side opposite the 30? What's the side opposite the 30? What do we make it? Okay, so I'll start filling in these things that you said. You got 30 here. That's where negative 330 lands. So 30, what's the side opposite the 30? Actually, let's move on because we have a lot of people. Brian, what's the side opposite the 30? What do we make it? Brian? What's the side opposite the 30? Either a letter or a number. Has to be memorized. Or we make x what? What number? That's simple. We used a. It doesn't matter. But what is the side opposite the 60 now? What's the multiplier on that? Good. And then what's the side opposite the 90? And then Ethan, R, this is a coordinate. Are they, is any of them negative? Yes or no? If I go root 3 right and 1 up, any of these negative? No, you're in quadrant 1. So let's start doing this. We have 4 people left, darn. And there's only 3 questions left. Oh well. What's the sign of negative 330 then, Ethan? Oops, sorry. Opposite. Yep, you got it. Adjacent and hypotenuse, because it's the reference angle that we deal those sides with here. I know it said weird, but that's the reference angle, so that's why we do that. So yes, it's 1/2. Next, Kayla, what's cosine of negative 330? No. Ka. And then I guess I could do the Sydney. What's the tangent of negative 330? And then hold on. Then Patrick, what's 1 over 1 root 3 or 1 over root 3? What do I have to do with that, or what does it become? Root 3 over 3, rationalizing. Absolutely. All right, and then some things I'm going to imagine I'll do throughout the week. Maybe on Thursday, Friday, we'll clean this up, but then I'll talk about the other 3 trig functions, which isn't a big deal. And I'll write it right now. Cosecant is just the flip of sine. So the cosecant of negative 330 is just 2 over 1. Ain't no thing. It's not a big deal. The flip of cosine is secant. So the secant of negative 330 is 2 over root 3, which means rationalizing 2 root 3 over 3. So it's not really a big deal to introduce these things, because that's all it really is. And then cotan is the flip of this. So cotan of negative 330 is the flip of tan. And you don't want to flip this, you want to flip this. You end up with root 3. So I figured I'd talk more about those. The other hour, I didn't even talk about these other 3. It really isn't a big deal. So that shouldn't be a big deal to deal with. Okay, then I'm going to just show you what I got here. This is what the video is going to be about that you're going to have to do on your own. So watch those other 2 videos that I told you about, the other 2 people, real short, concise lessons. Then I'm going to move on with radian measure, and then I'm going to go back and fill out this unit circle with corresponding radian measures. All right, and then that's the part that you're really going to have to solidify and be good with. And then we'll do trig on those. So that just gives you an idea what's happening. Okay? All right, I already took attendance with taking a screenshot of you guys, so don't leave yet here. Let me just make sure. And then I'll stop sharing. That's not what I wanted to stop sharing. Stop sharing the video.